Yeah, welcome, good morning, and welcome to the electrical testing for computer part. Today in this session, we'll be seeing experiment 5, in which we'll see how to use the counters, and we will also see how to use the robot machine with the bitmap device as well. Okay. Before I begin, I would like to share you how to see the experiments of electronics part. Go to your Blackboard and click on this online classes. When you click on these online classes, you will see here you see experiment for computer part. Okay, if you missed this experiment for computer part, I have given you the link. I think it was old now, but for see this one, experiment for electronics part. Okay, here I have given you all the links where you can click on this link. You click on this link, automatically it will open a YouTube link to that experiment, and you will see the electronics part experiment which has been demonstrated here. So you can see very clearly the video here. Similarly, you can click on this link. For part A you have 4 links, and part B you have 1 link, and part C you have 1 link. Okay. And for the computer part, today I will be showing you experiment 5. Then you can submit me the experiment 5 on this link. Okay, experiment 5 computer. Okay, submit here. This is the link for laptop. You have to click on this. Okay, after clicking on this, you will get a screen. Here you need to write the write your lab report, and make a PDF file using CAN scanner or any software of your choice, and click on this browse computer and select that file. Okay, click on open. Okay, and then submit it, and make sure that you can submit only one file. So if you have 4 or 5 pages, then create a single file. Okay, and submit them all together. This is how you will be submitting experiment 5 to me. Okay, and other things, this is how you will do that. Okay, and most suppose if you don't have software at your home, here I have told you how to install multimedia logic simulator in your laptop. Okay, or into your desktop. Click on this link. Okay, it will show you how to install the multimedia logic software. Okay, which I have shown here in the video, which will help you in installing all this software. Let me show you. Just you have to click on this play, and automatically you see it will help you. This is only a 9-minute video which helps you all the steps. It will show you all the steps for installing the multimedia logic software. Okay. Similarly, if you want, where is your lab manual? All this information is present here. Okay, lab manual, test books, and all. I have opened the discussion forum also. If you have any concern and want to share with your friends and me, we will have a discussion board also here. Okay, so I hope you have understood this. Now let's go and start our experiment 5 using multimedia logic simulator. Before that, let me show you that where is our software. Okay, so click on this multimedia logic simulator, and then click on this close. This is our multimedia logic simulator. I just make it zoom out, zoom in. Okay, now let us see the experiment 5. Okay, here you'll see that this is your experiment 5. Okay, you know that you have to write your name and ID and today's date here, which is what the date you are seeing. And the first 2 experiments are very simple because already you know that this is switch, this is push button. Okay, and this is about you give connections. That's all. Okay, So it will be very, I think I need not go into this. Just this D latch flip-flop is designed with the help of this circuit. Okay, so you have only these two part which you can do very easily because you already have been through these components, switch, push button, and this is NAND gates, this is LED. So this is not our concern that you can do at this point of, I think you can do it very easily. Now, the concern is about this third and fourth part, which are a little bit big components for you. Of course, this is also, you have completed LED and counter, ground, push button, and LED. You have already completed this. But because in this experiment diagram, you might not be knowing just by seeing how these connections are given. Okay. So to help you out, I will show you these connections, okay, how you will give the connections. So first see here, we have two push buttons, okay, and we have one ground, and we have one counter, and we have 7 segment LED in one quantity, and then we have 4 LEDs. Okay, so let's go back to our multimedia logic simulator, and we will go to the switches. So we need two switches according to the diagram, but these are not switches, these are push buttons, they are momentary switches. So what do you do? We will right click on this switch and go to properties, and in type we will select momentary and click OK. So the same thing we will repeat for the another switch as well to make it push button. So now we got two push buttons. After this, you need to take one ground device, and you see here you have a ground device. So let's go and connect this, put the ground device here, and you have enter. So let's see where is the counter. This is the counter. So let's go and we will just put this counter. Okay, and you have one 7 segment LED. So here you got 7 segment LED. Let's put this 7 segment LED, and followed by you have four LEDs. Okay, so 1, 2, 3, 4. Okay, now let's give the connections. When you carefully look to this, from this switch, from this push button we are giving to CT, and from here we are giving to reset, and ground is given to D. Okay, and from 0 to 3 I give connection from 0 to 3, and at the same time we are connecting from 0 to 3 to LED 1, 2, 4, 8. Okay, now actually why I have given this number 1248, because you see as shown in the diagram, this is the number 9. Okay, this 9 is in hexadecimal. Okay, so this hexadecimal is converted into binary. In hexadecimal, this 7 segment LED gives you hexadecimal value, and to represent a hexadecimal number, a single hexadecimal digit, we need 4 bits. Okay, so these are the 4 bits. Okay, and in binary, you know that first bit takes 1, second bit takes 2, 4, 8, 16, 32, right? So because we need only 4 bits, I have taken only up to 4. Now 9, how do you write in binary? 1001. So when the counter count 9, it will show you in binary, you see 1001. Okay, so for this you can draw the table also. How can you draw the table? You can draw the table as the hexadecimal value and the binary equivalent here. Okay, so now let us see live how after giving the connections it will work. So I give from this push button to this CT, no problem, and then from this to the reset, this is great. Then from the ground we give it to the device D. Okay, now look here, from this 0 I give connection to this 0 of LED, and at the same time we give this 0 to this as well. Okay, then next I give from this 1 to 7 segment LED, and at the same time we will give it this to LED as well. Then at the third step I give it to 0, 1, 2 and at the same time I will give connection to this LED as well. And finally, I give 3 to 3, and this will be given to the fourth LED. Now, see, this is not connected. This is when counter overflow, it gives you this out carry. Okay, so I'm not using carry here. If you want, you can use it, but because according to our experiment here, it's not used. Now let's give labeling now. How do you give labeling? Before we give labeling, let me, okay, let me just, so these connections I have given, just by seeing this you may not be knowing, because I have told you that how to give connections earlier, right? So let's use this text, and I just give here the names. Let's give it as 1, this is as 2, this is as 4, and this is as 8. Okay, now let's simulate it. When I run this, 0. When it is 0, you see all are 0, 0, 0, 0. Now I just count it. 1 in binary, this is 1. When I count 2 in binary, 2 is 0, 0, 1, 0. 3 in binary is 0, 0, 1, 1. Correct? 4, 0, 1, 0, 0. 5, 0, 1, 0, 1. 6 is 0, 1, 1, 0. 7, 0, triple 1. 4 is 1, triple 0. Okay, 8. And 9 is, this is what I have shown here, 9. Okay, so it's 9. Then you have 10. 10 is not written here because it's an hexadecimal. It will give you A. A means 10. Okay, 8 plus 2, 10. Then you have B is 11. So 8 plus 2 plus 1 is 11. Then C is 12. 8 plus 4 is 12. And D is 13. 8 plus 4 plus 1. And this is 14. 8 plus 4, 12 plus 2, 14. F is 15. All are ones. After this, it will be an overflow here. So because I didn't connect it here, we didn't see the output. So all will become 0. So this is how this experiment is connected. Okay. So
Doctor.
Understood? You have any question?
Yes, doctor. Doctor,
Any
are you
question?
hearing me?
No question.
Doctor. Doctor.
Okay.
Doctor, are you hearing me?
So Muhammad Jaber also joined us. Great. So let's see now. Yeah. Okay. So no problem. Let's go for the next part now. Okay. Now, how do you check? Let's go for the new experiment. Which experiment? Let's go to this.
Doctor.
Okay, this is about robot. Implementing the following robot circuit. Okay, now we are using robot, and car should show its path with line. Now you see, this is a machine, a robot machine. It should derive a car. Okay, so this is a bitmap BMP. Okay, do you get any questions? No. Okay.
Doctor.
So this is a BMP file where all the routes will be displayed, and this is a image car. So I want to derive this car from one point to another point. Okay. So for this, I'm using see, I'm using one image, this car image, and also I'm using this BMP, and I'm using this robot machine, and I'm also using this switch and using this select device and oscillator. Now see here, so far in all the experiments, you might have used this switch and select and oscillator, right? But you have not used these 3 components. What are those? This robot, this BMP, and this bitmap, and this is an image. Okay, so let me show you about what is this bitmap file, how does it work. Let's go to your textbook. Okay, where is the textbook? You know that textbook, go to your courses, and here you will find textbooks and materials. When you click this, okay, you will get this textbooks. Now here I just my bitmap to just understand how does it works. Okay. Where is this bitmap? No. Yeah, here is the bitmap device. You see, the bitmap device is a very powerful out device. It is an output device. Okay. Now, what it will do, it will allow you to display bitmaps. Okay, which is based on some inputs to your circuit. Okay. Now, you can choose up to 16 different bitmaps from 4 inputs. You see, it has given the 4 inputs, so you can choose 2 to the power of 4 is nothing but 16 bitmaps. Okay, and because we know that we have a counter, the counter also counts from 0 to F. You have seen in the previous experiments. So we can hook a counter to this device also. Okay, to get a device to sequence through a set of similar bitmaps. Okay, to get an animation effect, we can create an animation with the help of selected device as well. Okay, you can, if you have a car, then you can show that a car is running. If you have a person is running. Okay, all these kind of animations you can show with the help of this bitmap things. And another device which we have is the robot. Okay, let's see how this robot device look like. Yeah, you see, this is your robot device. Okay, now it has some strange connections. It's a very basic machine actually. Okay, now you have to build the hardware to give it any intelligence. Okay, but the good point is it is linked with bitmap. In bitmap, whatever you give the instructions, it follows here. Okay, so the bitmap device acts as the robot's playground. You must enable a bitmap device to be a playground. I'll show you how to do that. Okay, the robot bitmap name must be of the form of this .bmp file. Okay, you have to give bitmap pixels. Okay, bmp file is should be given to the simulator. Okay, there are some already available car 0, car 1, car 2 bitmaps are already available. When you install this software, you will get this all free of cost. Okay, so let us go back and give the connections, and there are some rules that same size they should be, and if the different value of d, then the robot moves east, west, north, south. When you see the experiment, you'll understand how what I'm going to demonstrate now. Okay, so let's go and make it big, and let us see our experiment here. We have one switch and one select device and one oscillator and one robot machine bitmap. Okay, so let's get, I'm just putting one switch. Let's go for the select device. Okay, and also we have an oscillator. Do you see here we have an oscillator? Okay, so now see, a lot of things are not just by seeing this, you will not get all the properties and all the settings. Okay, so listen carefully, and in report you have to mention only what are the new components you have used in experiment 5. Okay, and the working of those new components and the procedure of this circuit, how you give connections and set the properties, all this you have to mention. Okay, so now let's get a robot. Now you see, this is the robot here. Right, we got a robot here. Okay, and also we have to get one bmp. You see, this is bitmap. I click on this bitmap, this will give me a bitmap. Now these are only just about the components in a plain manner. Now we have to do settings here. Okay, what settings we'll do here? You see, let's go first. Click on this selector and right click on this robot and click on properties. Okay, when you click on properties, you will see that it is drawing. Click on this drawing, okay, and click on this browse, okay. So when you click on this browse, you just select car 0. As I have told you, it will come you free of cost, okay. Then you click on open, okay, okay. So just you have to do this change. And another BMP, what you have to do is right click. Now the car what I have selected, it should display on this screen. For that, you have to go to the properties of this, okay, and make robot as a playground, okay, and click okay. Properties, okay. Now when you make it robot a playground, you should also select the ground playground, okay. This is not sufficient, so I just browse and I will go to colors.bmp, okay. So I just give this link to this and click OK. Now you see I got the roadway, correct? But here to put car onto this roadway, I go to the properties, click on this, okay, go to this program files, right? I have already told you that we have selected this car.bmp, okay. This already we have done it, but when you run, it will show you this. Now let's see how you give the connections, okay. This is very important. Now for giving these connections, let's see, from this switch we are giving it to this P, and now you need to be very careful while giving these connections, okay. Let's give this oscillator to machine, okay, M. Now look here, I think in the diagram it is not clear how you have given the connections. Now look here, from this point I give it to 0, and again from this point I have to give it to this 0 as well, okay, like this. Take this wire, sorry, let me just do some adjustments, okay. Now here I take this 0 and put onto this 0, and at the same time from same 0 I put to this 0 as well, okay. This is what I'm doing. It is not clear from here, that's why I'm showing you here, okay. The next one, take one and put this one here, okay, and from the same one put it to 1, okay, and this third simply give 3 also. Now I'm not giving to this fourth input because I'll show you afterwards if you give also, you know, how the image moves and all. Now look here, this is how I have given the connections. Let us run this now. When you run, you see the car image. What we have is running now. You see, car is running. Okay, yeah. One more thing, when I run, the car is running, but what I want is how it is taking the path. I want that route also. So while it is moving, it should draw a line also. So for that, what I will do is I will go this and click onto this properties and make it on. Click OK. Okay, when I do this, now let us see, when I run the simulator, you see this is working, right? This is drawing its thing. Now, right, this doesn't work now. It's only for one time. Okay, so understood now. Now look here again. I just run. Okay, but we have given some BMP file to the selected device also. Let's see what happens. Wow, it's coming back. It's going this side and going that side. It's moving. Great. Nice. You see, the car is moving in all directions. But it is so fast, I cannot control it. Okay, it is very fast. Wherever you want, you can take. Now, what I do is stop it. Oh, any problem? Oh, I think there is some problem. No need. Oh, I'm fear the program is lost. Oh, program is lost. I have to give the connections again. So let's go where I'll do it fastly. Okay, so we have a switch, and then we have oscillator. We have a select device. We have a robot. We have a BMP. Okay, and let's give this connections, make this property drawing. Okay, and I just give this connections, this 0 to this 0, 0, and I give this 1 to 1, 1 to 1. This is 3 is given to the machine. Okay, I think I have to give some more properties. Go to this and select this car. Okay, and go to this properties, make it robot, browse for colors. Okay, okay. So when I run this, it is running, and you know that when I make it properties as on, okay, when I run, it is running. Now this time I will do one more thing. Let's go to the properties of oscillator, and I give 50,000. Okay, and now you see it's moving very slowly. Okay, that's nice. Now it is drawing. When I just push this, now it will leave the drawing. It will not draw now. You see, now it is drawing. Now I can control my car very easily now. Yes, so if you want to move anywhere, yeah, I can move. You can make your car go easily. Oh, go back. Yeah, now I want to take it in this direction here. So let's move up to this point. When it move in this point, then I will make it take right. Okay, so my car is moving across all the colors. Let's do it here. Okay, it's very far. So here when it comes, I want to make this car in this direction. Oh no, yeah, oh no, it's very small. Yeah, see, it's moving in that direction. You see all this here I draw, here I didn't draw. Okay, all these things you'll see that we able to use this robot machine as well. So hope you enjoyed this experiment. Okay, you can also do this experiment at your laptop. So I just stop it. So
Doctor,
let me go back to the screen. Okay, so
Doctor,
hope you guys enjoyed this experiment. Okay, this is our experiment 5. Okay,
Doctor.
yeah, any question? Nasir Ali Qasim,
Yes,
you have any question?
yes, yes, Doctor. Are you hearing me?
Yes.
But, Doctor, I have a question in experiment 1.
Nasir, you have any question?
Yes.
Yeah, please ask me.
Doctor,
No, I didn't hear you.
Doctor,
I didn't hear
Doctor,
your voice.
Doctor. X.
So you can
Doctor.
type your question. I didn't hear your voice. If you want to talk, I think you have to on your microphone and then speak. Okay, which experiment part 1? This You mean this?
For the table.
Flip-flops? No, yeah, just leave the table. You know that how JK RS flip-flop and D flip-flop works, okay? You have to give the circuit and write that table, okay? That's all. Which you have already done, I think, in testing too. So that's why I didn't repeat it. You can in table you have to write that how the generally you know that how this flip-flop works, okay? Set and reset button. If it is reset, okay, then what is the internal and previous state? Or the thing is important is you just give connections, okay? Leave the table because it's last experiment and is very easy. So leave this. Only you just practice that you can give the connections, okay? No need of table here. But the important is part C and D, okay? In part C, you should know how to give connections and also draw the table. In table, in one column, you have to write all hexadecimal numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. And on other side, you have to write the binary equivalent by seeing in the circuit, okay? And in last part, part D, okay, you have to explain the connections of robot, okay? Yes, 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 because part A and part B components are already completed. Okay. Yes. Any other question? No, don't draw. Don't draw part D. You have the report already. You can take that printout and write the procedure about it. New component and how you have given connections. Explanation about robot machine, BMP, what I've explained. That you have to write. Okay. And part C, give the connections and write the table. That's all. Okay. Any other question? Yes, part C, you have table. Okay, I will show you how to draw the table for part C. Now look here, you might be seeing here, okay? This is for part C table, okay?
Okay.
Now what you have to do is, you have to draw a table, okay? Like this. Okay, so here you have to write X number, and here you have to write binary. In hex number you have to write 0, 1, okay? So on, okay, 2, sorry, 0, this is 1, then you have 2, then you have 3, sorry, I just draw again. You have table like this. Total you have to draw 16 columns, okay? So on, dot 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 dot, so on you have to draw, okay? And here you have to write, okay, here hex number, and here you will write binary equivalent. according to that. So you see here you have 0 and you have 1, you have 2, so on. You might have somewhere like A, okay, like this. So here binary equivalent 0, 0, 0, 0, 1, 0, 0, 1, 0, 10 means 1, 0, 1, 0, so on, like this. Okay, this is what you give. Click on counter. Okay, this counter will give you the in 7 segment LED this value, hex number. You can write here hex number in hex number displayed in 7 segment LED, huh? And here binary equivalent, this is shown by LEDs. Okay, this is how you have to draw the table. Okay, it's clear now. Okay, no problem, you can send me next week. Okay. Okay, so great. Hope you have enjoyed this experiment, robot part, right? Yeah, what is the last question? Yeah, what is the last question? I'm waiting for your question. This is what it is attached here. No, this last experiment. This is actually the student has to do on its own, but because it's on learning, I've shown you just a new component how to give connections in your own words. Because by this time, I think you have got the experience of how to do the reports and write in your own way. Okay, so this experiment 5 is to see that how well you can write in your without my help. Okay, so now up to 4 experiments, I've helped you how to write the reports and given you steps and some points and told you to organize properly, right? But this experiment 5, I have just shown you the experiment. Now you have to organize your report properly, okay, and submit it. Okay, great. Any other question? Oh, yeah, welcome, and uh, I hope you have enjoyed this experiment. Okay. Yeah, Jaber, any other question? So, okay, so I will stop here. Okay, let's see next week. Okay, thank you.